All right, it's time for weekly essential number 10. We're getting really close to the end of course test, so it's becoming really important that these weekly essentials be completed and understood. All right, the first one asks us to solve this equation for y. So as far as I'm concerned, I'm going to act like y is really the only variable in this, even though I see that there is an x. Okay, I want to get y by itself. 90% of the time we get rid of anything that's added or subtracted, so we typically move the entire x term to the other side by subtracting 5x from both sides. That will give us negative 3y equals negative 5x plus 15. We typically put the x term first on the right side of the equation because a lot of times when we're solving for y, we're trying to get it in slope-intercept form, mx plus b. Okay, still trying to get that y by itself, still want y over here, nothing but y. So I'm going to get rid of the times negative 3 by dividing both sides by negative 3. And the quick way to divide everything on this side by negative 3 is to divide each term. Okay, on the left, those will reduce. Okay, on the right, we have some that will reduce and some that won't. Okay, the one thing we know for sure here about this first term is that a negative divided by a negative becomes a positive. Okay, so we'll put positive 5/3. Break out that variable x. Now the second term does simplify. 15 can be divided evenly by negative 3, so we put plus 5. So there is that equation solved for y. All right, number 2, a social media website currently has 1,000 members. The number of people that joins a website triples every month. That's one of those big keywords. Triples tells us that this has to be an exponential equation. After how many months will the website have more than 1 million members? So our basic exponential equation is y equals a times b to the x. Okay, a is going to be the starting amount, and b is going to be the rate. What are we multiplying by over and over again? So first I'm going to set up a basic equation. Y equals, let's see, starting with 1,000 members, we are tripling each time period, each month. Okay? All right, x is the number of months, y is the number of members after x months. Okay? We want to end up with 1 million members. So in the place of y, I'm going to substitute that 1 million. Now, unfortunately, we don't really have a method for solving exponential equations unless both sides can be written with the same base, and that's just not going to happen this time. Okay, so what we're going to do is just kind of make a table. Okay, remember that x represents the number of months and y represents the number of members. Okay, so we're just going to have to make a table and see how long will it really take to get 1 million members. Okay, so if I plug in 0 for x, meaning 0 months have passed since we started counting, then that gives us that initial amount of 1,000. Okay, if I substitute in a 1 for x here, okay, 1,000 times 3 to the first power, that'll be 3,000. Okay, substitute in a 2. Okay, and remember, essentially what we're doing is multiplying by 3. Plug in a 2 for x, 1,000 times 3 to the second. 3 to the second is 9, times 1,000 is 9,000. Or you could just remember that what I'm doing each time is taking the previous amount and tripling it, multiplying it by 3. Okay, so let's go with that. Let's keep going. I'm going to multiply this by 3. It'll give me 27,000 members, 4 months. 81,000. Okay, we're getting closer. 5 months. 243,000. 6 months. Triple it again. 729,000. Okay, now I'm gonna have to go to my calculator for this one. Okay, at 7 months, we finally have made it to 2,187,000 members. So the question was, after how many months will it have more than 1 million members? After 6 months, it only had 729,000. So it would take a little less probably than 7 months. But that's the first time we're aware of that it is more than 1 million members. And I just realized here, I set it as an equation, but we really don't want it to be an equation. We really want it to be an inequality. We want this number of members here to be greater than or equal to 1 million. Okay? All right. Given the function f of x equals 3x plus 4, compare f of x to 3 times f of x. Okay, the first key here is an understanding that this is really just 3 multiplied by f of x. So 3 multiplied by that f of x function, which was given as 3x plus 4. That gives us 9x plus 12. Okay. All right, part B, compare f of x to f of 3x. This is different. This tells us in the place of every x, substitute a 3x. So I'm going to copy down the original function, 3 input plus 4, and I'm going to use 3x as my input. Okay. The only thing I can really simplify here is 3 times 3x. That gives me 9x plus 4. Okay. All right, which has the fastest growth rate? F of x, 3 times f of x, or f of 3x? Okay, well, growth rate is another way of saying rate of change or slope. Okay, so let's make a little table here. F of x, 3f of x, and f of 3x. Okay, so what is the slope for each one? Okay, well, for the original function, the slope was 3. Okay. For the 3f of x, the slope turned out to be 9. Okay, and then finally, for f of 3x, the slope turned out to be 9 again. Okay, so 2 of these are growing at equal rates. So 3f of x and f of 3x grow at a rate of 9. Okay, so they both have the fastest growth rate. They tied. All right, number 4, graph the inequality. Okay, if you remember when we graph a linear inequality, we have a boundary line and then we shade on one side or the other. So first thing we need to do is solve this for y, get it in slope-intercept form so that we can figure out where the boundary line is. And then we'll decide is that boundary line solid or dotted. So if x plus 2y is less than 4, we want to get y by itself, just like we did in the very first example up there. The only difference is that was an equation and this one's an inequality. We have 2y is less than negative x plus 4. Okay, divide every term by 2. Okay, we have to remember this is understood to have a coefficient of 1 in front of that x. So y is less than negative 1/2 x plus 2. Okay, so that means that the slope of the boundary line is negative 1/2. The y-intercept of the boundary line is the point 0, 2. Okay, so graph that y-intercept first, and then a slope of negative 1/2 tells us to move down 1 and right 2, down 1 and right 2. I like to do this as many times as I can, and I can even reverse it and go up 1 and left 2. Okay, now, if that boundary line is included as part of the solution, then I would make it a solid line. Because this is a less than and not a less than or equal to, then it's not going to include that boundary line. So I'm going to make this a solid line to let me know that my shading should go right up to that boundary line, but not include that boundary line. Okay? All right, and then because the y values are less than this line, then I want to shade y values that are below that line. Okay, so if I color this, everything that satisfy this, it's all the points that are below that boundary line. Okay, so something like that. All right, number 5. Use a number line to display the solution to 7 minus 4x is greater than or equal to 3. Okay, let's first solve it to find out what the solutions are. Okay, now there's only one variable this time, so we only need one dimension. We need a number line, not a coordinate plane. This is going to be a graph of all the solutions for x, right? So just like always, let me get that x by itself. I'm going to subtract 7 from both sides. And then I'm going to divide both sides by that negative 4. Now, one thing you have to remember about inequalities, if you divide both sides or multiply both sides by a negative number, it will switch the sense of the inequality. In order for this to be true, x has to be less than or equal to positive 1. Now, depending on the teacher, they may want you to put several numbers on another line. You may want to label a few more numbers. I don't typically require my students to label a bunch of numbers because really, honestly, the only number that's important here is that critical value of 1. Okay, now just like when I did the coordinate plane in number 4, anything that I darken is part of the solution. So because this one has the equal, I'm going to darken in 1 by putting a closed dot on 1. And then I want to shade all the x's that are less than 1. So I'm going to shade everything to the left of 1, including making that arrow big and dark to show that there are solutions that continue forever in that direction. Okay, number 6, Peg and Larry purchased no contract cell phones. Okay, Peg's phone costs $25 plus 25 cents per minute. Larry's phone costs $35 plus 20 cents per minute. After how many minutes of use will Peg's phone cost more than Larry's phone? Okay, so let's write a function for Peg. Okay, her function will be $25, that's her initial fee, plus 25 cents per minute. Okay, and Larry, for his cell phone, okay, let's use g of x for Larry. His is $35. He has to pay an initial fee that's higher, but he only has to pay 20 cents per minute. Okay, so initially Larry's is higher because he has to pay that $35 flat fee. But I want to know when is it that Peg's phone will cost more. So I'm going to set Peg's function greater than Larry's function. And then I'm going to solve this inequality for x. Okay, first thing I'm going to do, I notice that I have x's on both sides. Okay, so I'm going to subtract the 0.2x from both sides. And that'll give me 25 plus 0.05x is greater than 35. Now I'm going to subtract the 25 from both sides. Okay, let's come over here and work this. 0.05x is greater than 10. And then finally, I'm going to divide both sides by 0.05. So x is greater than 10 divided by 0.05. Let's go ahead and work that out in the calculator. So 200. Okay, so at any number of minutes greater than 200, Peg's cell phone plan will cost more. Okay, all right, number 7. All right, we have our exponential function, 3 to the x. Find the function that represents a 5-unit translation up of the function. Okay, so we have learned that anything that's added or subtracted is going to cause a shift or a translation. Okay, if the function moves up, then that means that the 5 was added outside of the function. Okay, and then for part B, if the translation is to the right or to the left, that means it was contained within the function. So it's in the exponent with x. And if we, in order to translate 5 units to the right, we actually, it seems like it should be plus 5, but it's really a minus 5. And that one has to be in the exponent. Okay. All right, number 8. Okay, the parent function is f of x equals mx plus b. Okay, that should be screaming linear function to you. What is the value of the parameter m? Okay, parameter is a fancy word. We'll see if that matters. For the line passing through the points 1, 5, and -2, 0. Okay, well, parameter is a fancy word. Okay, but we know that m stands for slope. So if this is a linear function and we're trying to find the value of m, essentially what we're doing is finding the slope. Okay, on our formula sheet, we have a slope formula, y2 minus y1. over x2 minus x1. Okay, 1 is x1, that's the x from the first point, and then 5 is y1. This is x2 and y2. Okay, so we're going to substitute in those numbers into this formula. All right, y2, the y from the second point is 0, y1 is 5, x2 is negative 2, x1 is 1. Okay, fraction bar acts like a parenthesis, separating the top from the bottom. Let's work both of those out. 0 minus 5 is negative 5. Negative 2 minus 1 is negative 3. Now that will not simplify in such a way that it would divide out evenly, but again, like the one we had before, the one thing we do know is that a negative over a negative gives us a positive 5/3, and it's okay to leave a slope as an improper fraction. Okay, number 9, 2 populations of ants have been growing according to the data shown in the table. And this is missing the table, so I'm just going to fill this in real quick. Okay, all right, if this is months, okay, we want, let's make that, sorry. Okay, months and population. Okay, so let's make it 1 month and 2 month, and let's make it 500 ants and then 600 ants. Okay, all right. This population is increasing at a constant rate each month, and we're asked to find the rate at which the population is increasing. Okay, so increasing at a constant rate should make you think, well, that's a linear function. Linear functions have a constant rate of change. So essentially, I'm just finding the slope. Well, again, just like the one prior to this, 600 minus 500 over 2 minus 1. So that's 100 over 1. Okay, so the ants are growing 100 ants per month. Okay, and that kind of makes sense. From 500 to 600, you grew 100 ants in 1 month. Now, part B is different. The population is increasing by a constant percent each month. Okay, if you're growing by a percent every time, that leads us to an exponential function, y equals a times b to the x. Okay, well, in the case of the linear function, in order to find how much it grew by, we knew it was increasing by a certain amount, so we went backwards and subtracted. Well, if it is a exponential function, we know we're multiplying by the same amount each time. Okay, so the way that we're going to do that is go backwards and divide. So let's do 600 divided by 500. Okay, and the good thing is they only went up by 1, so we don't even really have to worry about the time unit. We can just do 600 divided by 100. Okay, all right, so what does that give us? Go to your calculator and do 600 divided by 500. Okay, that gives us 1.2. Okay, what does that tell us about the percent? Okay, well, let's think about this. If I wanted to convert this to a percent, our rule is move the decimal 2 places and add the percent sign. Okay, so that means it was 120% of the ants from the previous month. Okay, well, does that mean it was growing by 120%? No, remember that B is 1 plus R, okay, or 100% plus R percent. Okay, so if I take out the 100% from here, that tells me that I'm growing at a rate of 20%. Okay, now let's test that real quick. Okay, let's find 20% of 500. Okay, let's check. What is 20% of 500? So 0.20 times 500. That gives us 100. Did we actually grow by 100 ants? Yes, we did. So our answer of growing at a rate of a percent, 20% each month, is correct.